Hello everybody, Mr. Hennon here for another Henstitute Help. I grabbed number 4, 5, and 6 from the Newton's laws because they all involve using an old kinematic equation. So if you think about it, we have the definition of acceleration, that acceleration equals a change in velocity over time. And then we had a couple where we dealt with like initial velocity causing some kind of motion of the object, and then we had the one where you have a final velocity, but we don't have time. Now, these last two are not actually solved for acceleration, but we can still use them to solve for acceleration. Now, in each one of these problems, we're actually looking for the average net force. Average net force, what is the magnitude of the horizontal net force? So we're basically dealing with F. So we're also going to be using F equals ma. But we need to use these equations to find A first. So in number 4, if you kind of look at it, we are going from rest up to 45 meters per second in a time of 7 seconds. I think this is a great equation to start off with to figure out the acceleration of it, because this would be your VI, this would be your VF, and this would be your time. We're not going to do anything with 100 miles per hour. That's merely in there just to let you know that 45 meters per second is 100 miles per hour. Once I have A, then I can plug it into here to find my net force, because I also have the mass. So it's a combination of this lovely equation and this lovely equation. So 4 is probably the most straightforward. 5 and 6 throw you off a little bit because you're not sure which equation to use. I tried to make it so that we are using a little bit of every equation. So in number 5, we have the mass. This is the mass of our human cannonball. It's shot out of an 18-meter long cannon. So we're going to treat this as x. This is how far he's actually going to go. If the cannonball, or the human cannonball, spends 0.95 seconds in the cannon, determine the average force. So again, we're going to be using F equals ma, but we need to find A first. The equation I set up for this one is to use this equation. And you go, wait a second, I don't seem to have everything. I have time, I have x, but what about VI? Well, I kind of made the assumption that while the circus performer is inside of the cannon, he is at rest. So I kind of made the assumption that this part was 0. So if I look at that equation, I know x equals 1/2 at squared, because we got rid of the VIT. So if you were trying to solve this for A, the acceleration, you would multiply by 2. So I'd have 2x divided by t squared. So that will allow us to find the acceleration. Then I can plug the acceleration in there. Boom, I've got force. So nice and straightforward, nothing too complicated. The very last one. Again, we have the mass. This is the mass of the car. It's traveling with a speed of 15 meters per second. What is the magnitude of the force required to bring the car to a halt? So this would be our initial velocity, and this would be our final velocity over a distance of 50 meters. Really what this is saying, this would be your x. So now I've got it set up that we're going to use this last equation. But again, we're going to try to solve it for A. So the way it's already set up, the first thing I would do is let's subtract that VI squared over to the other side. So let's bring this over to the other side, and you get this. That VF squared minus VI squared equals 2AX. Then we can divide by the 2 and the x on both sides. By 2's, by x's, and we will just be left with A. Now I have the acceleration is this. Now looking at this, I know I'm starting with an initial velocity, but I'm finishing with 0. So this is going to be 0. I'm going to actually get a negative acceleration. Now they only ask for the magnitude of the force, so all I really need is I just need the magnitude of the acceleration. The reason why we're getting a negative is because we're slowing down. We know that this car is actually slowing down, but once I find this acceleration, I'm going to plug it in here. You can plug it in without the negative sign and solve for the mass, and you should be good. Hope that's a little bit of help on 4, 5, and 6 using those old kinematic equations as well as the new Newton's second law.